Alright, so we're going to get into 7.6 factoring ax squared plus bx plus c, but now that leading coefficient is not going to equal a 1 like it did in the last section. But before we get into doing that, I do want to do a quick warm-up. This is something I would have had you do in class, but I'll walk through it with you here. So this is what we were doing in the last section where that leading coefficient is a 1. So remember, if it says factor and it's a trinomial is factorable if it can be written as the product of two binomials. So that's what we were working on last section. That's what's going to happen in this problem here. So what times what would give you an x squared? Again, you're thinking if you had to FOIL these together, you should get back to that trinomial. So what two values multiply together to give you x squared? And that's, of course, x and x. And then the last two, when we FOIL, we do first, outside, inside, and last. And those last two are just going to be numbers. So those two numbers have to multiply together to give you that -7. So because 7 is prime, I know that I must have a 1 and a 7. Or you put 7 there and 1 here, it doesn't matter. But we need to get a positive 6x. So we could try a positive 1 here and a -7 there. But let's see what happens if we do that combination. So let me just show the work over here. If we have x plus 1 times x minus 7, notice the larger number is a negative, and we need a positive 6, which is much closer to 7 than it is to 1. So let's see what happens. If we distribute here, we get an x squared. Distribute here, we get a -7x. So I did the first outside, now the inside and last. Again, I'm talking about FOIL, a way to remember how to multiply two binomials together. First, outside, inside, last, which really just tells you distribute 4 times. Positive 1 times x is positive x, and positive 1 times -7 is -7. Combining the like terms in the middle there, we get an x squared minus 6x minus 7. So of course, this is a -6x, we need a positive 6x, so that is not the correct combination. So it must be a -1 and a positive 7. We can double check that real quick. If we FOIL this together, we get x squared. The outside 2 gives us a 7x. The inside 2 gives us a -x. And the last 2 gives us a -7. You combine those like terms in the middle, you get x squared plus 6x minus 7, and that is the same as the original trinomial. So this is the factored form of that trinomial. So that's just a review from the last section. That's what you had to do in your assignment. So let's try the next one. This is the new lesson. So this is where that leading coefficient is no longer a 1. It becomes a little bit more challenging than it was in the last section. But again, this topic that we're studying here is something you're going to be using a lot as you move forward in your math classes. So please put some effort into these assignments. I know you're doing homeschooling, but please, please, please put in a lot of effort to learning this material. Alright, so here we go. But it's still a trinomial. It still says factor. I put a note, notice a is not 1, which it's not, it's a 2. But it's still asking the same thing, to factor a trinomial. So a trinomial, again, is factorable if it can be written as the product of two binomials. So that didn't change. The only thing that changes is now we're not going to just have x and x here, because when you go to FOIL these, you'd get an x squared, and we'd be missing out on that 2. We need to have a 2x squared. Well, what times what gives you a 2? It's got to be a 2 and a 1. These numbers have to be integers. So you put a 2, and you don't have to put a 1. You could put a 1 here to hold the place, but it's an invisible 1. So 2x times x is 2x squared. We still have to think of the numbers that multiply to give us a 6. So in these last two positions here, I could try to put a positive 1. I could try to put a positive 6, because 1 times 6 is 6. But does that combination work? Well, let's go ahead and test that 1 and 6 out and see if we get what we started with. So if I try 2x plus 1 times x plus 6, and I FOIL, I get 2x squared. The outside 2 gives me a 12x. The inside 2 gives me a 1x, or just x, and the 1 times 6 is 6. Combine those like terms, and you can probably tell already that is not going to give me the original trinomial. I have a 13x in the middle here, whereas in the original trinomial, it's just a 7. So that combination, that was no good. So I've got to try another possibility. So this one, no good. Okay, so let's try 2x, let's see, two numbers that multiply give me a 6, I'll put a 2 and a 3. So 2x times x, I get 2x squared. Multiplying the 2x by 3, I get a 6x. The inside 2, I get 2x. And the last 2, I get 6. So again, I'm multiplying first, outside, inside, last, which just means distribute 4 times. All right, combine those middle two terms together and you get an 8x, but we don't need an 8x, so we need a 7x, so that also is not the correct combination. So you might be thinking, well, what else multiplies to 6? We tried 1 and 6, we tried 2 and 3. Those are the only combinations that multiply to 6. But with this one, we have to take this 2 into account. So notice when we go to multiply the first two together, we get 2x squared. The outside 2, we get 6x. So that 2 just affected how many x's we have. So you might think 2 times 3 is 6, but we could also try 3 times 2. So notice they're in the different positions. This is a 2 here, that's a 3 there, a 3 here, and now a 2 there. So let's see what happens when we FOIL those together. By the way, if you hear snoring in the background, my son is sleeping on the bed next to me, so sorry if this is awkward and you just hear snoring throughout this whole video. Anyway, moving on, let's test this one out. We have 2x plus 3 times x plus 2. Let's see if we get what we started with. So 2x times x is 2x squared. 2x times 2 is 4x. Inside is 3x. And last is 6. And on that one, if you combine those two middle terms, you get 2x squared plus 7x plus 6, and that is what we started with. So what happens when the leading coefficient is not 1, in this case it's a 2, it opens up more possibilities, more different cases that you have to test. Now the more that you do this, the faster you're going to start to realize what numbers you really need. You start to do this step over here in your head. And the process goes by much faster, and I'm intentionally kind of guiding you through some incorrect answers to get to the correct answer. So let's try one more. Again, it says factor. Again, it's a trinomial, and again, we have a leading coefficient that's not 1, but it's also a prime number, just like we had a prime on this last one. This is a prime number, so when I go to multiply, I must have a 3x and an x, because 3x times x is like 3x squared. There's no other way to get that 3 other than using a 3 and a 1. Alright, so the outside 2 have to multiply to negative 4, so pay attention to your symbols. That's a negative 4. So what two numbers multiply to negative 4? So that you've got some options. You could do positive 1, so let me write some possibilities down. We've got positive 1 and negative 4. But again, where we put these numbers now is significant when we don't have a leading coefficient of 1. So now we have to try 3x plus, 3x minus 4 here and x plus 1 there. Those are going to yield two different trinomials. So let's try those out first, and then we can maybe look at 2 and negative 2 and see if one of those would work if one of these doesn't already work. So FOIL first, we get 3x squared. Outside is negative 12x. Inside, positive x, and last, negative 4. So combine these middle two terms together, you get a negative 11x. That is not this middle term, so those are no good. Try the next one, you get 3x squared. The outside, we get 3x. Inside, negative 4x. And last, we get negative 4. If you combine those two middle terms together, you get a negative x, not a negative 4x. So again, that is no good. So let's try the possibility with 2 and a negative 2. So again, because the leading coefficient is not a 1, we might need a positive 2 here and a negative 2 there, or we might need a negative 2 here and a positive 2 there. We'll have to see. So 3x times x is 3x squared. The outside is a negative 6x. Inside is a positive 2x. And the last is a negative 4. Combine those together, and you end up getting that negative 4x. Like we needed in that original trinomial. So that is the factored form, 3x plus 2 times x minus 2. So let's just take a look at this real quick. On this one, when I go to distribute that 3x, I end up getting a negative 6x. The inside is going to be a positive 2x. I need a negative 4x on this one. So I need the negative. When I multiply 3 by negative 2, I get negative 6. I need the negative to be larger, more negative than the positive is, because my result must be a negative 4x, the negative 4x. So keep that in mind. That'll help you kind of eliminate some possibilities. I knew that I shouldn't have a negative 2 here and a positive 2 there, because then I'd end up with a positive 6x, and then it wouldn't turn into a negative in the end. So keep that in mind as we move on. All right, so example 3. Now this leading coefficient is a 4. So not only is it not a 1, but it is not a prime number. So that opens the door for even more possibilities. So this is probably one of the worst case scenarios you're going to find yourself in. You don't have a prime, you don't have a 1. So now we've got options. We can try 2x, and then we can try another 2x, because 2x times 2x is 4x squared. We still need two numbers at the end here that multiply to give us a 2. So it could be a 2 and a 1. But notice they have to multiply together to give me a positive 2. So I need a positive 2 here. And then look in the middle, there's a negative there. Well, what kind of numbers multiply together to give you a positive, but add together to give you a negative? And that's obviously two negatives. So I know that I need two negatives here because they will multiply to give me a positive. But I'm still going to have some negative x's to add together to be a negative 9x. So that's another hint. Looking at those symbols hints to you, or should hint to you, that you need, in this case, two negatives. If these are both positive, well, you need both positives. So start to look for patterns like that as you're doing these on your own. All right, so let's see what we've got here. If I FOIL this together, do I get that trinomial? 2x squared times 2x squared is 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. Negative 2 times 2x is negative 4x. And the last 2 gives me the positive 2. These middle terms do not combine to negative 9x, so that one is no good. All right, so I only get a negative 6x when I combine these together. That isn't enough negative x's to combine together. So let's try something different. Let's try a 4x in that first position. So what would have to go in the second position when I distribute here if I need a 4x squared? Well, 4x times x is 4x squared. The last two have to multiply together to give you a positive 2, so I need a 2 and a 1. So this is what I was talking about in the last example. We need a negative 9x. We need a bunch of negatives here. I'm thinking I need negative 8x's and another negative 1x. So how would I get that here? Well, if this on the outside multiplies together to give me a negative 8x, so if this is a 2, and then the inside gives me another negative x, so if that's a 1, that'll give me that negative 9x. So as I said, the more you do these, the more patterns you're going to see. All right, so let's just double check this one. If I were to distribute, I get 4x squared. The outside is negative 8x, the inside is negative x, and the last is 2. Combine those together, and you get negative 9x in the middle, and that is what we're looking for. 4x squared minus 9x plus 2. So this is the factored form of that trinomial. All right, the last example we're going to walk through has one extra step involved in it. It says we're going to factor. So again, if it's factorable, our answer should be the product of binomials. But on this one, it says we're going to factor this by first factoring out the greatest common factor. So look at these. We've got a 10. I should use a different color. We've got a 10 leading coefficient. We've got a negative 5 for our middle coefficients, and a negative 5 is our constant at the end. All of those have a common factor. All of those are divisible by 5. So I'm going to factor out a 5 on this one before I even start factoring like I did in the previous examples. So if I factor out the opposite of distributing in you multiply in. Factoring out, you're dividing out that 5. So I'm going to divide 5 from all three of these terms. I'm going to divide out a 5 from all three terms. So 10x squared divided by 5 is 2x squared. Negative 5x divided by 5 is negative 1x, or negative x. And negative 5 divided by 5 is a negative 1. So in other words, you could distribute the 5 back in, and you'd get 10x squared minus 5x minus 5, and that's what we started with. So what we have here is a trinomial. We're just going to carry this 5 down throughout our work. So as we go along, we'll just have a 5 sitting out in front of our binomials, and our answer will be 5 times the product of two binomials. All right, so on this one, I've got that 5 sitting out in front. I have a trinomial that will factor into the product of two binomials. And now I go through those steps. I've got a leading coefficient of 2, so I know that I need to have a 2x and an x, because 2x times x is 2x squared. That's the only possibility because 2 is prime. And I need two numbers that multiply to negative 1. So two negatives would not multiply to a negative, so that can't give me that negative 1. So I know I'm going to need one negative and one positive. I don't know if this one needs to be negative and that one needs to be positive. Well, actually, I kind of do in the back of my mind at this point, but I'm going to pretend like I don't know. So I'm just going to try some possibilities. And maybe, who knows, maybe I'll just get lucky on the first try here and I'll get it right. So let's see, if I have 2x plus some number and x minus some other number, and I need to get a negative 5 on the end, what would give me a negative 5? Well, that's another prime. It has to be a 5 times 1. Oh, I'm sorry, I was looking up here. That's no good. I'm factoring this trinomial. So I no longer care about the original trinomial. I am factoring this trinomial. So I said I needed a negative 5. I'm actually happy I made that mistake because some of you might do the same thing. We actually need a negative 1. So how do I get a negative 1? Well, obviously the only way here is if I have a 1 and negative 1. Those multiply to negative 1. So let's go ahead and double check and see if this is the factored form of that trinomial. So I'm going to leave that 5 alone there for a minute. I'm going to multiply my binomials together. So 2x times x is 2x squared. On the outside I get a negative 2x, inside a positive x, and the last two a negative 1. That 5 is still sitting out in front. Combining those like terms together in the middle, I get the quantity 2x squared minus x minus 1, and that 5 is still being multiplied on the outside, which could get distributed back in. And just to prove that this is the same, I mean, I can see that it's the same as what I had in the second step. So I could stop here and say, oh, yep, that must be the factored form, but just to prove it, I'll go ahead and distribute that 5 in and get 10x squared minus 5x minus 5, and that is the original trinomial. So that is the factored form. So I'll just write that over here. The factored form is 5 times the quantity 2x plus 1 times the quantity x minus 1. And that is the factored form, so that is the answer to this problem. I said that'd be the last one. I have the assignment here. I actually have one more listed on here that I was going to skip, but I might as well go through this now that you're not in class with me, so you don't have to worry about having extra homework time. So if you feel comfortable at this point, feel free to get to the assignment. It is an assignment called Factoring Polynomials when a is greater than 1, and it should be posted to Schoology. But I'll go ahead and go through one more with you. So on this one, just note on the assignment, it's not necessarily going to say by factoring out the greatest common factor in the directions. You just have to realize that you have to factor out the greatest common factor. If you don't, like if I didn't on this one, it's still possible to factor it as a trinomial, but my answer would look something like this. My answer would be something like, if I distribute 5 into one of these binomials, I get 10x plus 5. So my answer might look like this. Or if I distribute into the other one, I get 2x plus 1 times, if I distribute in the 5, I get 5x minus 5. So my answer might look like that. And if you look at these, you might notice 10 and 5 have a greatest common factor of 5. I could factor out a 5 here. Or 5x and negative 5, they've got that greatest common factor of 5, and I could factor out 5 there. So these answers, yeah, they're close to being correct, but they are not what is called factored completely, because you still have a greatest common factor within one of your binomials. So these are not the correct answers because they are not factored completely, because they still have a greatest common factor in them. This is the actual answer. So anytime you can take out a greatest common factor, do it right away. Not only are you going to be dealing with smaller numbers then, right here, with your trinomial that you're trying to factor, but also you're not going to make that mistake and be left with an answer that still has a greatest common factor. So right here, I didn't have to say it in the directions, but just take a look at these three terms. What is the greatest common factor between these three terms? What are they all divisible by? Hopefully you're thinking 4. Two of these terms have x's in them, the last one does not, so it's not 4x, it's just 4 that all three of these are divisible by. So if I factor out or divide out a 4, what remains? In other words, 4 times what gives me an 8x squared? Well, that's 2x. 4 times what gives me a 4x? Well, that's positive x. And 4 times what gives me a negative 4? Well, negative 1. There's two ways of looking at it. You can divide all of these by 4, or you can ask yourself, if you were to multiply it back in, what should you have there to get what you started with? All right, so again, we've got a trinomial here. We're going to carry this 4 down, this 4 here throughout our answer, and again our answer will be 4 times the product of two binomials. So we're going to try to factor this trinomial. We'll leave that 4 on the outside. Alright, so the product of two binomials, we have a prime number out in front as our leading coefficient, so that's nice. We have 2x times x, oh, I forgot my squared here. 2x times x gives me a 2x squared. I need two numbers that multiply to -1, and take a look in the middle here, we've got a positive x, so that should be a hint as to what symbols and even what numbers have to go there. The two numbers that multiply to -1, well, one's got to be positive, one's got to be negative, but it's going to be a positive 1 and a negative 1. I need to have these middle two terms add to a positive x, so I need the larger of the x's to be positive. I need a positive 2x and a negative 1x. So thinking of that, a positive 2x and a negative 1x, that tells me where my symbols need to go. Again, if you're not comfortable with that yet, that's okay. That comes with practice. You can try the different possibilities and then just cross out the ones that don't work and circle the one that does as your answer. That's okay. So let's just double check that this is the answer for this last example. So if I have 4 times the quantity 2x minus 1 times the quantity x plus 1, is that the factored form of that trinomial? Let's see. So I have 4 times, I'll FOIL these together, get 2x squared. The outside gives me a positive 2x, inside is negative x, and last is negative 1. Combine the like terms in the middle, I get 2x squared minus, plus x minus 1, and distribute the 4, and I get 8x squared plus 4x minus 4, which is the same as the original trinomial. So this is in fact the factored form of that trinomial. So that is my answer. So now, if you haven't already, please complete the assignment, Factoring Polynomials when a is greater than 1. It is a worksheet on Schoology. Please turn it in on Schoology. Thank you.